Yes, we are doing this question today.
Okay, sir.
Take your notebook and calculator as well.
Yes, sir, I have it.
Okay.
The three possible questions. Um,
Okay, we are given three balanced equations
yes, sir.
and only one of them is correct. Okay, but from the results that are shown, we have to prove that one of these equations only is correct. We are given the molecular masses of all the substances.
Yeah.
Okay, so we are supposed to follow the steps as per what information is given over here. Okay,
Yeah.
uh, in your notebook, just
Yes, sir.
copy down all of this data.
Okay, sir.
Just copy down this data.
Yes, sir. Yes, sir. Done, sir.
Correct. The first thing that we are supposed to find out is number of moles of NHCO3 used.
Yeah.
Okay. How are we going to do that?
From the RMM, you'll have to find that.
RMM is given.
Yeah. So
Correct.
that's 84 grams has 1 mole.
Okay. Simply whatever the mass is there, you divide it by its RMM.
Yeah.
They'll give you the number of moles.
So that's 84 upon 3.3. So the
No,
3
3.36 upon
84.
84. Just calculate how much is that.
0.04 moles.
Correct. Moles of NHCO3 used is 0.04
Mole.
mole. Okay.
Yeah.
Second part. Now the mass of residue is how much? 2.12 grams.
Yeah.
Correct.
Hmm.
This is the mass of the residue, that is 2.12 grams.
So that's 2.12 upon 62.
Correct. If it is Na2O by this equation, okay,
Yeah.
that is the first equation. If it is Na2O, then we are going to determine the number of moles of
Mole.
Na2O.
Yeah.
Correct. That is going to be what? Moles of,
Na2O will be 0.03.
that is 2.12 divided by
62.
62. How much is this?
0.03.
0.03. Okay. The next part that is there is if the residue is NaOH, number of moles of NaOH.
So there'll be 2.12 upon 40 gram.
Okay. If it
Yeah,
is NaOH, there will be 2.12 divided by 40. How much is this?
0.053.
0.053. Okay. And the
Yeah,
third case, if the residue is Na2CO3, number of moles of Na2CO3.
that'll be 2.12 upon 106.
Correct.
Yeah,
If it is NaHCO3, Na2CO3, there will be 2.12 divided by 106.
0.02 moles.
0.02. Okay. We have found out the moles of each one of these.
Yes, sir.
This obviously is the original substance used. Okay. So this value has to be there. And any one of these values will be correct as depending upon which equation is going to be the correct one.
Yeah,
Okay. You have written all these values, no? Moles of Na2O, NaOH and Na2CO3.
yeah, I wrote.
Okay. Now we'll just look into the equation. Okay.
Yeah,
So that is the third part of the question. Use the number of moles calculated in 1 and 2 to decide which of these is these three equations is correct. Explain your choice. Now we'll just look into the equation
yeah.
and then we'll try and find out which equation is the correct one. Okay. How much is the moles of NaHCO3 that we have found?
0.04.
How much is the moles of Na2O
0.
that you have found?
0.03.
0.03. How
First
much is
equation
the
is wrong.
okay moles of NaOH?
It's 0.053.
0.053. And moles of Na2CO3?
0.02.
0.02. Now
The
from all,
last,
correct, from all these values we have to determine which equation is correct.
yeah, so the last one is correct.
Can you tell me what is the reason why?
This is because the moles of NaHCO3 when divided by 2 should equal to the moles of the
Na2,
residue.
Na2CO3. Okay.
Yeah.
So this is 2 NaHCO3 and this is Na2CO3. So here the mole ratio is 2 is to 1.
Hmm.
And from the values that is given that we have found, okay, moles of NaHCO3 is 0.04 while the moles of residue that is remaining
Yeah.
for Na2CO3 is 0.02 whose ratio is also 2 is to 1.
Hmm.
Correct. So the third equation is the correct one. You understood the sum, no?
Yeah.
Okay. This one was that sum which I wanted to do with you. Yes, we'll do this one also.
You'll have to calculate the grams or the moles.
No,
One
no,
of them.
in the beginning there is no calculation. All calculations are coming later. Okay, just read the question carefully first.
Oh. You just have to add less of HCl and more of strontium chloride.
See, strontium chloride 6 water can be made from the insoluble compound strontium carbonate by the following reactions. Okay, the reactions are given. First, the
Yeah.
carbonate is converted into its chloride by action with acid, that is HCl. Okay,
Hmm.
then you are combining it water to give its crystalline form.
Hmm.
Okay, so first we are adding excess strontium carbonate to hot hydrochloric acid, filter the resulting mixture, partially evaporate the filtrate and allow it to cool. Filter off the crystals of SrCl2 6H2O, dry the crystals between filter papers. How would you know when excess strontium carbonate had been added up in step 1?
The amount of strontium carbonate will be more than HCl.
No, but how will you come to know? From the observation, you will have to tell that.
Oh. Oh, that's because there's the more ratios 1:2.
No. You see here, they have mentioned over here, this is an insoluble compound. So if strontium carbonate is excess, it means some insoluble substance is going to remain behind.
Yeah.
Right? Because we are using excess strontium carbonate and this is an insoluble compound. So if it is insoluble, then obviously you will be able to see that there is some insoluble substance left.
Yeah.
So from that you will come to know that excess strontium carbonate has been added in step 1.
Yeah.
Now why it is necessary to filter the mixture in step 2? These all are the questions from separation techniques.
This is because it should be pure, so that you get proper results.
Yes, correct. Okay, that's why
Yeah.
we have to filter it off.
Hmm.
Third question.
Three were partially evaporate or filtrate rather than evaporated. Right? I don't understand the question.
Why partially evaporate the filtrate rather
Hmm.
than evaporate it to
Oh,
dryness?
मतलब totally evaporate, but you evaporated half.
Yeah.
Mm. This is because you need the crystals, no? For crystallization
Yeah,
to take
obviously,
place.
because if you are going to evaporate to dryness, then what is going to happen? This will have to be heated.
Yeah.
In that case, again, it can form strontium chloride and water will get evaporated.
Hmm.
So we are not going to get the crystalline form of strontium chloride, that is SrCl2 6H2. We are not going to get partially. We are going to get what?
Strontium
Only,
chloride.
only strontium chloride also we can get. Okay,
Yeah.
that's the reason it has not to be evaporated to dryness.
Hmm.
Now the calculation part.
So the number of moles is concentration multiplied by the volume.
In this way, we are going to get number of moles of what?
HCl.
Correct. Find out the number of moles of HCl.
So that would be 100.
1 second. All right, its volume is 50 centimeter cube. This is for
Hmm.
HCl we are using.
Oh,
Okay,
yeah.
and its concentration is 2 moles per dm cube.
So you'll have to do 2 into 0.05.
Moles is equal to this centimeter cube is going to become 0.05 dm cube.
Yeah.
Correct. So that is going to be
0.1.
the concentration multiplied by its volume.
Volume.
Correct. That is going to be 2 multiplied by
0.5.
0.05. So the number of moles of HCl used is
0.1.
0.1 moles
Yeah.
HCl. Correct. 0.1 moles of HCl is used. This is what we have found out. So this you are going to write down this answer over here. Just make a note of that. The number of moles of HCl.
Yeah. Yes. Sir.
Okay.
Hmm.
Now number of moles of SrCl2 6H2O which could be formed. Okay. Now this you will have to look into the equation.
There'll be 1.
Correct.
No.
How much is this is 0.1 mole.
Huh.
So how much
There'll be
of
0.1 upon 2, no?
yeah. So this is
So that's
SrCO3 is going to become 0.
0.05.
This is going to become
Yeah.
0.05. This will also
Hmm.
give me 0.05
0.05.
SrCl2.
Strontium chloride. Yeah.
Correct. So this is also
Hmm.
0.05. So this also will be 0.05.
0.05. Hmm.
Correct. So the number of moles of SrCl2 6H2O that can be prepared from this is 0.05 moles.
Yeah.
Okay. So now number of moles of SrCl2 6H2O which could be formed. Here you will write down 0.05. Just make a note of that as well.
Yes, sir. Yeah.
Correct. Now the
Yeah.
molar mass of SrCl2 6H2O is already given to 67.
Hmm.
So theoretical yield, that is calculated yield of SrCl2 6H2O will be how many grams?
That'll be um six. Oh, you need the 0.05 upon 267, no?
Multiply.
Oh,
Correct.
yeah,
Because here we are finding the mass.
yeah,
Okay. So the mass is going to be the number of moles multiplied by RMM.
yeah,
Okay. So
will
this is
be
0.05 multiplied by RMM given is
267. The answer is 13.35.
13.35 grams. This much we should get.
Yeah,
But in actual, how much we are getting?
6.4.
So now you can find the percentage yield.
So that'll be theoretical upon
No. Theoretical will always be the calculated value that will come in the denominator.
6.4 upon 13.35 into 100. That's 47.94%.
Okay. We are not never going to get percentage yield more than 100%.
Yeah,
Correct. Because of some impurity or some other reasons, the percentage yield will always be less than 100%. Okay. So this theoretical yield part which is there, it will always come in the
yeah,
denominator. And the actual substance or mass that is obtained, that will always come in the numerator.
yeah.
Got that, no?
Yes, sir.
Okay. Other questions which are there from this worksheet, you can attempt it.
Yeah.
Okay. And you can type out the answers and send it to me here. Okay. You can solve it in your book, and you'll be able to type out the answers, and you will be able to send it to me. Okay. So these
Okay.
all questions I'm giving you for uh,
Homework.
homework.
Yeah.
Okay. Other questions which are there, they are quite easy. Okay. This way, these two questions which were there, they were a bit tricky.
Hmm.
Yes. The other things,
In physics, we started circular motion.
circular motion, but that topic is already there in general physics, no? That you have done before, no?
No, he skipped that small topic and he started now.
Okay.
Hmm.
You want to do that, or we'll continue with chemistry only? Because mole concept is almost like over. Only
Hmm.
past paper questions and different type of questions we are supposed to practice them.
Anything is fine. We can do circular motion next time also if you want.
Acha, okay, no problem.
Yeah.
But then we can just continue doing with stoichiometry these questions only.
Yeah.
Okay, because there is lots of work that I have given you.
Uh,
Okay, I don't think so we'll be able to finish everything before our next class.
that's
So
tomorrow. Tomorrow on Friday.
tomorrow I'll call you up if the class is. Tomorrow you have holiday in school, no?
Yeah.
Okay, tomorrow morning online if it is possible, then I'll call you up or I'll send you the message. Okay,
Yes, sir.
but then after that in the afternoon and evening I'm not free. Okay,
Yeah.
Friday I'm coming home at 8 o'clock at home.
Yeah.
Okay, yes, you can take up this question.
Yes, sir. So the white powder will be the equation is CuSO4 plus sulfur trioxide. Na?
No. See, the results of investigation into an action of heat on copper 2 sulfate 5 water.
Hmm.
So what is our equation going to be?
Oh, so copper to sulfate equals to with water.
CuSO4 dot 5H2O.
Yeah, it will be yeah.
This will be the equation.
Hmm.
See, I had shown you those crystals. These are blue crystals.
Yeah, yeah. And
And
that's
what is
what
this?
powder, blue powder.
No, it's white anhydrous. It's white powder.
Oh,
Okay, so what is the name of this white substance that is left behind? It is called anhydrous copper sulfate.
we have to specify now anhydrous.
Yes. If you just simply write copper sulfate, you are not going to get any marks for this.
Hmm. It's okay if we don't write two now.
Yeah. Okay, but here in the question it is given, so you better write it down.
Okay.
Okay, here in the question near 2 is given, so you write it down. So name the white powder, it is anhydrous copper 2
Sulfate.
sulfate. Second part,
Once absorbent water is added to the white powder. It will turn to copper sulfate dot 5 water.
correct. But then you will have to say the observation. You are telling what is produced.
It will change to a blue crystalline solid.
Correct. That's right. Okay, again it will turn into blue crystalline solids.
Yeah.
Okay.
Black powder will.
Now this is for the further part.
Oh,
Okay. You can see here a 5.0 gram sample of the blue crystals is heated to form 3.2 grams of white powder. With further heating, this decomposes into black powder and sulfur trioxide. Okay. Now you are supposed to name this black powder.
so that means copper sulfate is further heated.
Correct. First it becomes white powder. That white powder is then further heated. Okay. So CuSO4 that is there. This is the white powder that is further heated strongly. This is the white powder.
Hmm.
This
You get
becomes the black powder plus sulfur trioxide, which is
SO3. So you get CuS, copper
no, no.
sulfide.
Sulfur is already gone over here.
Oh, CuO, yeah.
It's
Copper
going to
oxide.
become CuO. This is going to be
Copper oxide,
copper.
2 oxide.
This color you need to remember it is black. Okay. Afterwards, I'll give you the chart of whichever colors of substances which you are supposed to remember.
Okay.
Okay. So copper 2 oxide is black in color. This is what you are supposed to remember. So the black powder is copper 2 sulfate.
Oxide.
Yeah, copper oxide. Sorry.
Yeah.
Now calculate the mass of the black powder. Show your working.
You'll have to take the mode ratio and then RMM, no?
Yes, that is for this equation. We'll have to consider that.
The
Okay.
1 is to
This
1 is to 1.
this we have taken how much? They have said it is 3.2 grams.
Oh, so that's um,
First you find here RMM of both.
40 plus 34 plus. Copper is 40, no?
Copper is 64.
That's 160 in grams. And CuO
Yes.
is 64 plus 16, that's 80.
Okay.
Hmm. So that means there is 3.2 into 80
Hmm.
upon 160.
Correct.
That's 1.6 grams of CuO.
Okay.
Yeah.
So from periodic table, we can attempt this question.
Um, it is. It's less. Compounds are colorful,
Okay. Colored compounds.
and I think the elements also are colored, right?
No, not. That's not. But the property that is required.
Um, they're
It will have.
metals.
Obviously, they have said that it's already given in the question.
No,
This will have high.
melting point and high boiling point.
Okay. This is the second property.
Three done na, high melting point and one high boiling point.
Yeah, obviously, they will have high melting and boiling points.
So three done.
No, this will be considered as 1 point only. One more property is required.
They are good conductors of electricity.
Obviously, they will be good conductors of electricity, and these are generally hard metals.
Um,
Okay,
there's a
next question.
there's a typical properties of transition metals. So do we have to? It's okay na, if we write metal properties also.
A typical typical transition element property means that is not specifically with other metals as well.
Oh,
Okay, so you cannot write just all the properties that are there for metals. Okay,
okay.
because they are specified here typical transition elements. Okay, which will be not there in other metals. Okay, so these are the three properties, and then the second part.
Eight.
What is the atomic number of manganese?
Um, I don't know.
Let's check. I'll just go to the periodic table. Yeah, where is Mn? It's a
Uh,
transition element. Yeah.
25.
Okay. Its atomic
Uh,
number is 25.
hmm.
So now
So
you are supposed to fill this.
that's 13.
Correct? 2, 8,
13.
13, 2. Because all this should add up to 25.
Yeah.
1 second. This is 10, 12, 13. Yeah, that's right. Okay, B part.
Uh, it'll be manganese chloride plus hydrogen oxide. No,
No,
plus water.
no, 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 no.
First time manganese chloride, na?
Yeah,
And there'll be
this will be.
water. Yeah.
Okay, in fact, actually, the equation is plus even chlorine gas is also produced.
Oh.
I don't know why it's not specified over here. Okay, second question, second part.
Sodium hydroxide. Sodium hydroxide is basic, na? So acidic. Manganese 4 oxide.
Okay. It will
Yeah.
react with acid oxide. Is it going to react with amphoteric oxide?
I don't know what's amphoteric.
You've not done the topic of acid bases.
Yeah, but we've not learned amphoteric.
You have finished the topic of acid bases.
Not in ninth grade. We did in seventh or
Okay,
sixth.
okay. Yeah, then it will come later. Fine.
What's sulfuryl chloride?
This this is sulfuryl chloride.
Uh, that is mass of sulfuryl chloride. Um, sulfur dioxide. It's 135 grams.
How can you say that? That's the mass of 1 mole. You can't take directly mass of 1 mole. By this equation, from the values that we are given, we are supposed to determine that.
Oh, the sulfur dioxide, the mole, that'll be 32 plus 16 into 2, 64. So 64 into, that'll be 8 upon 64. So 1 mole of the moles of sulfur dioxide used is 0.125.
Correct. Moles of SO2.
Hmm.
It's 8 divided by 64. That is 0.
Yeah, 125. So that's the same number of moles of sulfur chloride. So
So first, we'll just go do it stepwise. No, calculate the number of moles of Cl2 in the mixture. This is the second part also that they have asked.
uh, same thing, 0.125.
No, wait. There we are specified the mass of chlorine, which is 14.2 grams.
But the mole ratio is the same,
Yeah, yeah,
1 1.
obviously the mole ratio is going to be same. Only that much amount of chlorine is going to react, and only that much moles of SO2 Cl2 also will be produced. But here they have
Okay.
asked in the question, calculate the number of moles of Cl2 in the mixture. In the mixture means we are supposed to take this.
Okay. So that'll be 14.2 upon 35.5.
No,
That,
Cl2.
oh,
So 2 into 35.5.
yeah.
So that will be 14.2 upon 71.
So it's 0.2.
Okay, this will be 0.2 moles.
Yeah.
You see, because here one of them is the limiting reagent and one of them is in excess. Can you tell me here which is the limiting reagent?
SO2, sulfur dioxide.
Correct. SO2 Cl2 is the limiting reagent. So some amount of excess chlorine is going to remain.
Yeah.
Yes, this is what the next question is. Which reagent was not in excess?
That's chlorine. No. Yeah, sulfur dioxide, yeah.
Okay. SO2 is not in excess. So here you are going to write down SO2.
Yeah.
How many moles of SO2 Cl2 were formed?
That'll be 0.125.
Correct. This is
Yeah.
the limiting reagent. So that is going to be 0.125 over here.
Yeah.
Then the mass of sulfuryl chloride formed in grams.
So that's
How much?
135.
Hmm.
No, that's 0.125 upon 135.
Multiply. Always
That's
remember number of moles is equal to mass divided by its RMM. So if you are finding mass, this RMM will come over here, will get multiplied.
yeah,
Correct? So mass is equal to its
16.875.
multiplied by moles.
Yes.
In this case, it is 135 multiplied by 0.125. How much is the answer that you are getting by?
16.875.
Okay. So this will be 16.875.
875.
You will have to write it in terms of significant figures. You
That'll be
can see it all.
grams.
No, that's okay. But in all question also you can find here there is only one digit after the decimal point.
Yeah. So
8.0, 14.2. So you'll have to round it off according to one digit after the decimal point. So this will be rounded off, and we are going to
16.9
get 16.9 grams.
grams.
Got it?
Yeah. So the number of moles of this will be 400. No, we'll have to find the RMM of this.
It's given here.
Oh crap! I thought there was number more. Yeah, sorry.
Yeah, mass of 1 mole
So
means
that
RMM only.
yeah. So 400 is one mole. So how many grams is used?
So they've asked here number of moles.
We need how many grams is used? No.
First we will need number of moles of Fe2SO4 thrice. This part.
Oh yeah, 10 grams of iron sulfate is used. So yeah. So that will be 10 upon 400.
Correct. So just find that value.
0.025.
0.025. Okay. So here you are going to write. Just write that. Make a note of that value. Fe2SO3 moles.
Yeah. 2SO. 025.
Okay.
Yeah.
Moles of
Fe2.
Fe. Hmm. Right here they're not given here Fe2O3. So you'll have to find this
So it's the same
RMM.
now.
No, RMM. Moles
Oh,
will be same. Moles will be
yeah.
same. That will be
0.025.
0.025. So mass of iron 3 oxide, this you will have to find.
Yeah, so that's minus 56, huh?
Correct.
16 into 3 is 160. So 160 for 1. So that's 160 into 0.025.
Correct.
4 grams.
Okay. 4 grams of iron
Fe2.
3 oxide found.
Yeah.
Number of moles of SO3 produced.
Um, so that's 3 into 0.025.
Correct.
So 3 into 0.025. That's 0.075.
Correct. Here you will write 0.075.
75. Yeah.
Last part.
Volume of sulfur dioxide. So 1 mole has 24 dm cube. So that's 24 into 0.075.
Correct. For this you will simply multiply this by 24.
24. So that's 1.8 dm cube. Yeah.
Okay. These all kind of questions are going to be straightforward, simple.
Yeah. Next year. That will be 12 upon 281. No, 12 upon 119. No?
Number of moles of NiCO3. Okay, NiCO3 is given. Yeah. 12 upon 11. 9.
9. Yeah.
How much is
0.
that?
0.1.
Okay.
Mass of carbonate will be 0.1 moles. 1 mole of this much. 0.1 mole. You have to do 0.1 into 119.
1 second. This is incorrect. Huh? This is what you have calculated. This is the actually what is given to you, 12 grams. You see here, the moles of H2SO4 is how much?
0.08.
This mole ratio is how much?
Oh yeah,
This moles of NiCO3 that will react is going to be,
0.08.
now
Yeah,
the
that's
mass that has reacted,
0.08 into 119.
just calculate that.
That's 9.52.
Correct?
Yeah,
And finally, this you are supposed to find.
that's 9.52 12 minus 9.52,
Yeah, that will be
2.48.
okay.
Yeah. So that'll be 10.4 upon 2.48 and 200.
No,
No,
that is going to give you more than 100%.
10.4 upon 9.52. No.
No, that is the you are using here. All these are all calculations of nickel carbonate.
Oh, yeah. Um, how much is reacted?
See here,
Huh.
this mole ratio. This is 1. This is 1. Okay, and this is also 1.
Yeah.
Correct. So you all over here the mole ratio is 1:1. It means this 1 mole is going to produce 1 mole of this.
Yeah.
Correct. And how much of this substance we are using here?
0.08.
0.08 is reacting. So this also should produce how much?
0.08 grams.
Correct.
Yeah.
So no, not 0.08 grams. It's 0.08 moles.
Moles.
So how much mass of NiSO4 will be produced?
That is 0.08 into 281.
Correct. This both will get multiplied. That many grams
It's
of
20,
NiSO4 7H2O will be produced. How much is
22,
that?
22.48 grams.
22.48
20.
grams of
And,
NiSO4 7H2O. This is supposed to be produced. Okay.
yeah. Uh,
But here actually how much is formed?
10.4.
10.4. Now you can find the percentage. Maximum number of moles. This also will be 0.08.
Yeah.
Okay. Maximum mass. This is what you have found out.
22.4.
Now you can find the percentage yield from this
Yeah.
value.
10.4 upon 22.48 into 100. That's 46.26%.
Okay.
Yeah. The microhistorical salt is prepared when the resin acid is necessary for the cellular salt to separate protein from soluble base. Um, so you have to do base into acid, na? Base plus acid.
Yeah, but then you'll have to give the description of this method.
Um,
You have done. Okay, acid basis salts is not done. So that will come in methods of preparation of salts. Okay, it's a soluble salt. The method is neutralization, and
Yeah.
that part we are going to do when we do the topic of acid basis salts. Okay.
Okay. Yeah. Mix.
Okay, here we are supposed to find the empirical formula.
Yeah. Um,
Just get that.
so that'll be 4.8 plus 4.2 plus 9 plus 13.8 minus 9. So
Hmm.
sulfur is 4.8. 4.80.
Yeah.
Yeah. Number of moles will be um, copper has
Copper is atomic mass is 64.
oh yeah 64, so that's 1 mole, so 4.8 upon 64,
Just
that
calculate
is
that.
0.075, and iron is 56 upon 4, no, 4.2 upon 56,
Yeah.
that's same thing,
0.075.
and that's 4.8 upon 32, that's 0.15. So now you have to divide all by 0.075.
Okay.
The 1, 1, and 0, 2.
Okay.
Yeah, so
So the
the
empirical formula will be.
CuFeS2.
Okay.
Yeah.
This is the empirical formula.
Hmm.
Okay. This is a direct question.
Um, Number of moles of CaCO3. So that'll be,
First of all, we'll write down the equation.
yeah,
CaCO3 plus HCl.
CaCO2 plus X2. Yeah.
Okay. Mole ratio of these both is.
1 to 2. So that means 0.3 grams, 0.3 divided by 2. So 0.15 grams of CaCO3 is used.
No, no, don't say that. You just find out the number of moles straight away.
Um,
How much will be the number of moles?
of CaCO3, that will be 1, no,
What is marble?
CaCO3,
Yes. And mass given is how much?
0.3. Oh, I thought that was of HCl.
No. They have given here CaCO3. Okay.
Okay.
Mass of piece of marble is given 0.3 gram and
Yeah,
RMM is given. So directly you can find here the number of moles.
0.003.
And how many moles of HCl we are using?
That'll be 0.006.
No. You're not going to find it that way. We are going to use these values.
Oh, so that'll be moles equals to 5. 5 moles.
No. This is 5 centimeter cube. We will have to convert it
Oh
into
shit.
dm cube.
Yeah, so 0.005.
Okay, so this is 0.005.
Yeah.
Correct. Moles of CaCO3. This is what you have found.
Hmm.
Okay, this is 0.03, 003, 0.005. Now you tell which reagent is in excess.
HCl. No,
It's
yeah.
wrong. That's
Why?
wrong. The mole ratio is 1:2. So if this is 0.003, then this
Oh
has to
shit.
be 0.006.
Yeah.
So this is less.
Seriously.
So excess is CaCO3. Correct?
Yeah.
The reason over here is this. This is going to require double of this. And we are having only 5. We need 6.
Yeah.
Now the last part. Okay.
Hmm.
We are supposed to calculate the maximum volume of carbon dioxide that will be measured at
I
RTP. We'll just go back to the equation.
you. The mole ratio is 1:1, so the moles of carbon dioxide will be 0.003.
No, because here you see this is the limiting reagent
Yeah.
and this is excess. So we are never supposed to take excess. We are always supposed to take the minimum amount that is there. So
Okay.
if this is 0.005,
That will be 0.025.
0.025, correct? Because that much excess part which is there, that will remain unreacted.
Yeah.
And this is also going to produce same amount of
That's
carbon dioxide.
CO2. Yeah.
That's going to be 0.0025.
25.
Now you
So
find the volume of CO2.
concentration will be 24 dm cube, right?
Just multiply this by
24. So that's 0.06 dm.
okay. Yes, at least this question we will be able to do.
Percentage of hydrogen in the